Okay, we're continuing our study of logic here in chapter 2. This lesson is all about if-then statements, and if-then statements are conditional statements, and they even talk about that here in our notes. The phrase following the word if, or the beginning part of the phrase, is the hypothesis, and then the end is the conclusion. Then they give it to you in some letters. If P, then Q. P implies Q. Here is a good example down here. Example 2. You receive a free pizza with 12 coupons. Okay, well, if you're going to put that in if-then form, you would say, well, if you have 12 coupons, then you receive a free pizza. And if we're looking at this as hypothesis and conclusion, the hypothesis is if you have 12 coupons, then the conclusion, you're going to receive a free pizza. Regardless of the order, regardless how this first shows up, there has to be something forcing the action, and then there has to be an outcome. For instance, it doesn't really make sense to say you get a free pizza because you have, or you get a free pizza for the 12 coupons. You had the 12 coupons first, got the free pizza. I hope that makes sense. Let's try an example here. Our first one, what they want us to do is identify the hypothesis and the conclusion. So if it is Saturday, then there is no school. Okay, well, remember, what comes after if is the hypothesis, so that's H, and then there's no school, C, conclusion. If x minus 8 is 32, then x is 40. Again, hypothesis, conclusion. Okay? And then if a polygon has 4 right angles, then the polygon is a rectangle. Hypothesis, conclusion. Pretty easy. Hypothesis at the beginning, conclusion at the end. Okay? Now, what they want us to do here is kind of like what happened up here. You will receive a free pizza with 12 coupons, and then it was kind of rearranged and expanded a little bit to form that statement. So we have something like all apes love bananas. Well, what we could say is maybe if an animal, loves bananas, then it is an ape. Okay. So then we have hypothesis up front, if an animal loves bananas, conclusion at the end. Now, these if-thens don't have to be necessarily 100% true. That's going to be for us to evaluate here in a little bit, and we'll see that down below in 7 and 8. We have to evaluate truth or false, and then if it's true, explain it. If it's false, give a counterexample. Okay, number 5. The sum of the measures of complementary angles is 90 degrees. So what we could say is if the sum of angles is 90 degrees, they are complementary. They are complementary. If the sum of angles is 90 degrees, they are complementary. Okay. And then number 6, collinear points lie on the same line. If points lie on the same line, they are collinear. Okay, so now let's go down below and look at truth or false. So we already have an if-then statement. It says, if today is Wednesday, then yesterday was Friday. Okay, here's the problem with that. That doesn't make any sense. Because if today is Wednesday, then yesterday was definitely not Friday. It was Tuesday. So first thing we'll say is false. And we can very easily provide a counterexample. If today is Wednesday, then yesterday was Tuesday. So we just have to change this word here. So if today is Wednesday, and I'm going to abbreviate WEDS. If today is Wednesday, then yesterday was Tuesday. Okay, that's what we're going to do together, and then you guys can try the back page by yourselves. If A is positive, then 10A is greater than A. And as long as A is positive, multiplying it by 10 is going to give you a larger number. So this is true. And they want us to explain our reasoning. Okay, well, let's pick a number for A. I'm going to go with 3. So let's say 3 is equal to A, and that's definitely positive. So if we multiply that by 10, 3 times 10 is 30. And then we could simply say that 3 is definitely not as big as 30. Hopefully this helps a little bit on if-then statements, and I would like for you to try the back page on your own and complete the book assignments as well.